Hello. Those of you who don't know me, my name is Eden and I'm the TA for Gen Chem 1. Today I'm going to be going over the practice exam number 2. I didn't print out the exam. I have it on my computer and you guys can follow along with the questions. So I'm going to start with question number 1. So what is the ground state electron configuration of manganese? Manganese has 25 protons, so this is the atomic number. So we know that it's over here. So this is our S block, this is our P block, this is our D block, and then this is our F block. So right off the bat, we can start looking, and we can see that 1s1 and 1s2 are filled. So I'm going to go ahead and write that. And then we're going to go to the second line and see that 2s1 and 2s2 are filled. So I'm going to write that too. And then I'm going to go over to the 2p. So 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6 are all filled as well. And then we're going to go over to the third line where we have 3s2 and 3p1, 2, 3, 4, 5, and 6. Because remember, our element is right here. So we have 3s2 and then we have 3p6, which are all filled. And now we get to this line. So this line, this is 4, this is the S block. We know it's 4s1 and 4s2. However, when we get to this block, the D block, this line is actually number 3. It's actually here. So this is 3d1, 3d2, 3d3, 3d4, and 3d5. And since this is 3 and not 4, even though it's in the D block and in the fourth line, 3D comes before 4s2. So what that means is we're going to write 3d5, 4s2. And this is the electron configuration for a ground state manganese. And this is answer choice number B for question 1. And then question 2. Question 2 tells us that in the laboratory, acid spills are often neutralized by adding sodium bicarbonate. What is the mass of sodium bicarbonate that reacts with 225 milliliters of 6.0 molar HCl? So this is 225 milliliters of 6.0 molar HCl. And then they give us the equation. And I'm not going to write the whole equation. I'm just going to write the ratio of H+, which comes from HCl, and sodium bicarbonate. So we see that this is a ratio of 1 to 1. So that means that the same number of moles that are added in here are going to be the same number of moles that are added, or vice versa. The same number of moles of HCl that you added is going to be the same number of sodium bicarbonate that you need in order to neutralize that. So I'm going to figure out the number of moles, because if we remember the definition of molarity, I'm going to write right here, molarity equals moles over volume. So we have 6.0 equal moles over liters, because that's moles over volume. And we have X amount of moles and 225 ml divided by 1,000, or if you want to do ratio or converting it, it's 1 liter over 1,000 milliliter, and the milliliters cancel out, and this either way gives us 0.225 liters. So when we multiply this, I'm going to go ahead and multiply it. So 6.0 times 0.225, I get 1.35 moles. But that's not what they're asking for. They're not asking for the moles. They're asking for the mass. So what we have to remember is so far we calculated the moles of HCl, but we're looking for the mass of sodium bicarbonate. So we know that there is a mole ratio of 1:1 between HCl and sodium bicarbonate. So I'm going to go ahead and convert this into moles of sodium bicarbonate. So I'm going to put 1 mole of HCl on the bottom over 1 mole of sodium bicarbonate on the top. And I'm going to get 1.35 moles of sodium bicarbonate. So in order to convert this into mass or into grams, which is what I need to know the molecular weight of this compound. So I'm going to go ahead and calculate that. So I have sodium, I have hydrogen, I have carbon, and I have 3 oxygens. So using the periodic table, I'm just going to get the atomic mass of each of these elements. So sodium is 22.99, hydrogen is 1.008, carbon is 12.01, and oxygen is 16 times 3. So I'm going to get the total mass by adding all of these up. Plus 16 times 3. And I get that the total mass is 84.008. And this is grams per mole. This is for sodium bicarbonate. So now, in order to find the mass, I'm going to use this ratio, which is moles equals mass over molar mass. So I have the moles and I have the molar mass, and now I can find the regular mass. So I'm going to get 1.35 equals x over 84.008, and I'm going to cross multiply. So I get 1.35 times 84.008. I get x equals 113.4. And if we round that up to 3 sig figs, we're going to get 113. And that is answer choice number C.